All right, so as we continue lesson 34 this morning about implicit differentiation, Amelia, what did it mean that I had an implicit equation?
There was an x and y on both sides.
Yeah, there's x's and y's on both sides. The explicit equation just says y equals something. The implicit has multiple y's, and there really is no easy way to get y by itself. Even on this equation, I can't get y by itself. If I try to factor, I would still have a y on the left-hand side of the question. We actually ended with this example yesterday of our y squared minus xy equals sine x. And yesterday's question, we located what was dy over dx. Today, as we start our question, we're now going to reverse it. And we're going to see if we can find dx over dy. So using the same example that we stopped with yesterday, let's see if we can locate what this derivative is of dx over dy. In order to do a derivative when it comes to an implicit question, it was a three-step process. Josiah, what was the first step on implicit differentiation?
You find the derivative.
You do the derivative, and you do the derivative for every single part of the question. The first part of my question was y squared. What was the derivative of y squared? And anyone can answer that?
2y.
It was 2y, and what must I include? Because I'm doing a differential dy, because our variable was y. So 2y dy. Now, we saw this part yesterday because this was the exact same equation. Behind the minus, I have a product. The product involves two pieces when I go to do its differential. So I have to make sure behind that subtraction I put a parenthesis to make sure I'm going to subtract the entire part of my question. How did I do a derivative or a differential from a product? I began with the first term, which was x. Then I did the derivative or the differential of the second term, y. What is the differential for y? It was just dy. Knocking the exponent down gives us 1y to the 0. Y to the 0 disappears, so I just have 1, and our variable was y. So dy. A product has a plus in the middle, and then I reverse it. I now take the second term, which was the y, and then the differential of the first term was the differential of x. It is dx. Again, rotating the exponent down makes 1x to the 0. X to the 0 disappears, so I just have the dx left in our question. Do the same process on the right side. We have a sine x. What is the derivative of sine x? Cosine x. And because we're doing a differential in step 1, I need to include that dx in our question. Okay, so that's step number 1. We just did the differential of every single piece of the question. Before I switch to step number 2, because this question has parentheses, just like we did yesterday, we're going to go ahead and distribute. So I have 2y dy minus x dy minus y dx equals cosine x dx. Alright, so now we're ready for step number 2. Josiah, do you remember what step number 2 tells us to do for the implicit differentiation?
We would divide by dy.
Very good. So I'm looking at what does the question say. I'm trying to find the derivative with respect to y. That means I need to divide every single piece of our question by the dy that is in our denominator. Yesterday, when we tried to find dy over dx, we divided every single part by dx. Today, the dy is in the denominator, so I divide every single part by dy in our question. Let's come back through and simplify to see what can happen on our question. Does anything reduce on the first fraction? The dy. I have 1 on the top, 1 on the bottom, so those two can cross each other off. We are just left with the 2y and then our minus sign. What about the second fraction? Can I do anything there? The dy again, the same differential on the top and the bottom. They cross each other off, just leaving us with the x. What about the third fraction? What can I do there? Nothing. Dx and dy are not the same differential. I cannot get rid of those. And that's helpful because the question says to do dx over dy, I need to have that in the question. The same thing would happen on the right side. There's nothing over there that I can reduce or cancel, so that stays as cosine x dx over dy. So number 2, we divided by what we are attempting to find on our question. And what is step number 3, the final step?
Solve for what you're finding.
Solve for what you're attempting to find, so solve algebraically. My job is to find dx over dy. Amelia, can you tell me what would be the first step if I want to solve for dx over dy?
Would you factor out the dx over dy?
I don't want to do that yet, because all the dx's, dy's are not together yet.
So we would add it over.
Very good. So I'm going to take this term that's right here, because on the left side, that's the only piece that has the dx over dy. The right side, that's all it has, is the dx, dy's. So let's go ahead and add that y dx over dy to the right side of our equation. And let me switch so I can use the whiteboard now. The left side of the equation is still identical. It still says 2y minus x. The right side of our equation, I cannot add or subtract those because they're not like terms. I have my cosine x, and that was dx over dy. And then I added over that second piece of our y dx dy. Okay, now everything that has the dx, dy is on the right side of the equation. So what's the next thing I do, Colin, if I wanted to continue to solve there? So I'm looking for dx over dy, what is in both of those terms. And this is what Amelia just told me a second ago to do, but we weren't quite ready for that.
I forget.
Okay, so Amelia, what did you say? Now we're going to factor it out. So because it's part of both of the terms, I want to factor it out to the front. What does that leave me with from the first term? Just the cosine x. And what does that leave me with from the second term?
Y.
Just the y. We have one last step, and Josiah, what's the last step on this question?
Yeah, divide.
Very good. So this is the fraction I want by itself. Divide by what's next to that fraction of our cosine x over cosine x plus y. And there is my answer for the derivative with respect to y. Now, before I go to the next example, what do we notice between the answer from yesterday, when the question said dy over dx, and the answer that we just got today, when it said dx over dy? Anything you notice between the last answer from yesterday and this first answer from this morning? They're flipped. It's just the reciprocal, because the question was a reciprocal. Yesterday's question said dy over dx. Today's question says dx over dy. It's just been flipped upside down, so I flipped our answer upside down as well in our question. Okay, you guys with me so far with this implicit differentiation? Alright, so I'm going to see if you guys can complete this next question for me. Now on the next question, the original equation is still the same. The y squared minus xy equals sine x. So we've already done the derivative a couple different times now. So you actually can start right there in the question. The derivative, or the differential. So write down that differential problem that we've done twice now with your dx's, dy's. This time you're trying to find dt. So you would divide everything by dt. differential that we've come up with twice already. I'm looking for dy over dt, so I'm going to divide everything by dt. Now, a difference here that we haven't seen on the other examples that we did yesterday, and we've already seen this morning, I don't have anything. That's going to cancel out at this point of the question. None of the numerators have a dt. So all of the pieces of my question are still fractions. It still says 2y dy